Hello everybody, hope you had good night's sleep. So my name is Sohil Thakkar and I am a technical product manager for wireless LAN portfolio at Extreme Networks. I have about 12 years of Wi-Fi industry experience, starting with research to engineering, and then finally I ended up in a PLM role. So, I'm with the industry, like even in the school, in my undergrad, in my master's, I was basically, I did the thesis on Wi-Fi networks, and then basically worked for Fujitsu Labs, did some research over there, and then moved on to a startup called BlueSocket. And there basically, I was there for 5 years, and basically I designed their virtual WLAN wireless LAN solution. And then eventually that company was sold to Atran, and then I basically decided to move on, and I joined Enterasys in 2013, early, like in January 2013. As technical product manager, and then as all of you know, that Enterasys network was acquired by Extreme Networks last November. So now we are all part of Extreme Network. So overall, how many of you guys know about Extreme Networks? Okay, all right. So we are basically now with the merger of two companies of roughly the equal size. When Enterasys merged with Extreme, we were basically roughly the same size. So now, new Extreme with the new logo and everything and that's the present. We released the new logo last week, and that's the presentation that's the corporate deck that I'm using, or template I'm using for this presentation. So as a new Extreme, we are about 1,700 employees. And basically about 12,000 global customers. Some of our key customers are are essentially that you can you can relate to are like NFL stadiums, like Gillette Stadium. It's all end-to-end Enterasys network. Extreme Networks. So wireless, wired network, as well as the analytics engine. Lincoln Financial Field, which is again home of Philadelphia Eagles. So there it's wireless is Extreme Networks Wireless, wired network is Brocade, and then analytics engine is again Extreme Networks. So that's the stadium. We have like big schools like USC, UNC, and then hospitals like Henry Ford Hospital Systems, and few others which are like large customers. In K through 12, we have over 500 school districts with about 5,000 sites or schools that is using Extreme Networks wireless. And we have basically wireless deployment in every state in US. So today we will talk about the deployments and how we designed a network in K through 12 in vertical. What I want to put out it up front is, this is basically based on the experience that we have gained over the years, and that includes not only myself but people in field, and it's not only at Extreme Networks, but also at BlueSocket and other places where I have been. What I do want is I want to learn from you guys as well, so that if there are differences or different approaches that you guys are taking, it would be good, it would benefit all of us, that if you share that, so that we can create the best design. So having said that, this is the approach that I take when it comes to designing networks. And primarily, the current role that I am in, I mostly interface with sales engineers who are ultimately going to go and either deploy it or who will work with partners to deploy the network. So first thing that I always ask is, what are the business requirements that you are trying to solve? Without knowing that business requirement, you cannot really design a network that solves a problem, because at the end of the day, wireless network needs to deliver something. It's not bits and bytes, it's not bandwidth, it's not latency. It is some applications that is running on the network that needs to deliver some user experience. And what is that user experience that you are trying to achieve? And knowing that will help guide, make engineering decisions when you deploy your network. So that's the first fundamental question. What is the business requirement you are trying to solve? And for K through 12, we'll see in slides later what are some of those major trends, and basically what are those requirements and what that would translate in, or how they translate into technical requirements. But that's rule number one. Understand the business requirement. It is important not only to understand the business requirement from the customer end point of view, but also knowing those requirements, you will know how you will be judged when you deliver the network. So that, this is the most fundamental piece where you can see that if not handled properly, the outcome at the end of the deployment may not be something that customer may not be happy, you may not be happy as an individual, or it could be other way around, right? So where you have deployed an overkill solution, and then basically like year or 2 years down the line, customer comes back to say, okay, you sold me so many things, but I'm just using half of my network, right? So that's why it's really important that we understand the business requirement and how the deployment would be judged. So how do we know what are the business requirements? And this is specifically true for customers in K through 12, because remember, the school district and school administrators, many of them do not have networking background, right? So many times they themselves don't know why they are designing the network or what they are ultimately trying to achieve with it, right? So as a technical expert, our job is to educate the customer in terms of what are the things that is happening, what are the things that they need to look out for, and what do we see as being in the field, like 3 years, 4 years down the line, how the network would look like. And having that conversation is very important, because that not only enables you to identify customer requirements, but also establish that trust between you and the customer, right? So essentially, there are like 4 major trends that are going on in K through 12 market, and this is specific. Many of these things are specific to US, right? Take example of common core standards. So that's basically a requirement for like how the education is imparted, as well as how kids are assessed, or teachers are assessed in terms of delivering the instruction, right? So that and we'll talk about that later. The next one is the digital content. So way we were taught, or at least if I can relate to myself, 20 years back, 30 years back, I was sitting you would sit in the bench and teachers would deliver instruction, whether you listen or not, doesn't matter. With the digital content, now things are changing. You have many more tools to enable and enrich the learning environment. And there are technologies that are in the classrooms that enable kids to learn where they can absorb most of the information, right? So those are the trends that are going on in K through 12. Other is the connected learning space, and that's, again, we'll talk about some of the initiatives that came out of Microsoft or Bill Gates' education initiatives, something that he's working with, like Khan Academy. Means, I don't know, have you guys heard of that? Or right? So basically, it's also called flip learning, where basically the idea is student would basically listen to the instruction at home, and then when they come to school, they would actually do the assignment based on those instructions. And the role of the teacher is to go around and help kids understand that instruction if they don't understand it. And while kids are solving those assignments, they are connected to the backend server, so that, let's say you take an example of a math problem, say 5 plus 5, right? If kid took 3 tries to get the right answer, all those 3 tries are recorded, right? So that teacher can know whether how well a student has grasped the concept, and how long it took him to grasp that concept, right? So what it means is there is a major implication on the network, right? Because now you are always connected. All those assessment needs to go back over the network, right? So those it has an implication on how you design the network. And the fourth is basically what are the devices that are out there, and whether it's school is providing end devices to students, or students are bringing their own devices, which is basically BYOD trend. And all these trends, right, rely on networking technology to enable students to enrich their learning. Okay. For some reason, it didn't move, so let's see. Okay. All right, so it moved. All right, so what is Common Core Standard? So it's basically a standard which is pursued by like 45 states in US. There are 5 states which are not participating. But so majority of the US has adopted this standard in one form or other. And the goal there is to ensure that kids are learning what they should learn, and there is an assessment component, online assessment component to it, so that you can evaluate how students are doing, and how teachers are basically, that's also a component of how teachers are being evaluated as well. That has many implications on, so this has a many implication on the networking side. Specifically, where those tools are, for example, all those assessment tools are, and that would have implication in terms of how you traffic engineer your network, right? So take an example where your application which is doing the assessment, right? The backend for that assessment is living in cloud, right? Now, what that means from the application or traffic engineering point of view, what it means is all your traffic is going through internet, and you have to secure it. It's all most likely HTTPS traffic, but it is exiting from the school's network onto internet. Whereas you could take another example where if there is a big district, they might host those application server in that data center, and they those at the district level, they own the MPLS links between the schools, and all those assessment tools are centrally located. So in that case, the traffic is not going to the internet, but it is just traversing your WAN network. So, those kind of deployments have different traffic engineering implications. So, and we will look at those further down the line, right? Other thing is those educational apps, right? Means what are they doing? What are the bandwidth requirement, latency requirement, security requirements? So all those also comes into picture. And when we design a network, we need to consider those. Next one is the digital content. Again, what are the digital contents? Content means textbooks. No longer they are many schools are now migrating to electronic textbooks, right? So you don't have the paper textbooks, but you have an iPad, and you are basically looking at a textbook, which is many times hosted in the cloud or at the data center, and kids just get it when they are in school. Same way the video content. Instruction is delivered by specialized teacher, and then, so teachers are there in the class, but the information is delivered via video content, and then teacher's job is to ensure that students have grasped the concepts, answer their question, and help them in their assignment, right? There are interactive applications where, and it's based on like some of the gaming research, where it's a different way to teach kids different concepts, right? So where there is more interaction going on, whether it's in a gaming fashion or there is a collaboration between students, right? So, so these are basically some of the applications which are very heavy in bandwidth use. Specifically, like once you put the video in it requires, and particularly HD video, it requires a lot of bandwidth, right? So what it means for the network which is carrying that traffic, right? So it's basically, again, you need to understand what are the bandwidth requirements, what are the latency requirement, and it also has implication on RF. Because if it is single, all the kids in a classroom receiving that video, if that video application is unicast and not multicast, then you have to ensure that you have that 2 or 3 megabits pipe to each of the student in a classroom, right? How do you do that at the RF level? So that has an implication on how you design RF. Next is the connected learning space, and again, that's basically the example that I talked about. There is also an, electronic blackboards and other things which are again related to connected learning space. Other thing that we have lately noticed is classroom is no longer now organized around teacher and kids in front of teachers. There are spatial activity areas that either for on a given day of a week or on some schedule, basically there are different groups within the classroom, and then the different activity happens in that classroom. And then end of the day, everything is changed, and next day you go to the classroom, it's basically used in a relatively different way, right? And we have seen this mostly in private schools, and like Montessori schools or schools which are basically more focused on experience-based learning, right? And again, so there it's your RF environment, or you cannot really assume that putting the AP right in the middle is going to be the best thing to do, right? So again, the implication is how do you provide best coverage all across your classroom? And again, the applications that you are using means what is the characteristics of those applications. Many times these applications have a heavy upload requirement compared to download requirement, because when kids are learning based on the experience, that experience is what is captured by this application and uploaded to the server for analysis later down the line, right? So that's where there is slight difference in terms of downlink versus uplink requirements. But again, that's something that knowing the business requirement helps you understand and then design your network accordingly. And then there are initiatives where it's one-to-one initiative, where essentially district or school districts provide a laptop or a learning tool to kids. And that's a relatively easy case to solve, because then you can standardize on, okay, I have a MacBook or Android tablet or Windows laptop, and I have to design for only those kind of devices, right? So you know those devices beforehand, and then you are designing the network based on that. On the other extreme, you have BYOD, where kids are required to bring the devices at school, whatever they can afford, and that basically depending on the school district and ability of kids' parent, you would see wide variety of devices. And many times those are not the latest devices, because most of the kids, right, means their parents would give their 1 or 2 year old or 3 year old devices to those kids to get to the school, right? So you will see 11B client, 11G client, no, and basically which have no capacity of 11N. Forget about 11AC, right? So then you need to basically, when you are designing the network, basically you need to know what kind of clients you need to service, right? So and that has again design implication in terms of how many devices you can support, how many applications you can support, and all that. So once you know the business application, what you need to basically then come down to is, okay, so what exactly I'm trying to design for, right? So typically what we do is we kind of try to identify and learn from interacting with customer, or if customer doesn't provide it, means we have a mechanism where if customer chooses, they can actually provide feedback to Extreme Networks their device mix, and basically we kind of average it out, and we provide basically or we know typically what would go in the classroom, right? So this is one example of it. This is dated in the sense this is probably 6 months old, right? But again, so what we have seen in typical K through 12 environment which is using BYOD is, you see these are the set of devices that and the percentage of those devices in typical classroom, right? So you can see, right, that it's tablets and netbooks are more prevalent, and many of them supports 2.4 as well as 5 gigahertz. But then if you look at other devices, some of them are not supporting 5 gigahertz at all, right? And on this side, it's basically capability. So at least, so this is what is a picture of a typical deployment, where you will see at the percentage level what kind of devices you expect to see in K through 12. Once you know the device mix, next thing is you need to know what is the application mix is. And this is again set of applications that we have seen in K through 12. Again, their characteristics on the right hand side and the percentage on the left hand side, right? We have this tool where you can actually modify it. So depending on means if on a specific customer requirement, you can actually modify any of this, or you can add any other application that you want. It's not a spreadsheet. It's a tool. So it's an application that we provide to customer as well as partners. I believe that all the other vendors should have similar thing, because it's means whatever vendor that you are working with, means if you are a partner or a customer, means they should have similar thing. Means whether they share it at the end customer level or basically they share it at the partner level, that it depends vendor by vendor, but most of the vendors should have this, right? But the idea here is to understand the customer requirement, and that translated into the technical requirement, and then basically using those requirements to design the network, right? So once you have the application device mix and you have the application mix, you can compute how many users and how many devices you can support on per AP basis, right? So that's your, at the basic level, this is your building block. So one AP can support 26, in this particular case, 26 devices, right? And this is concurrent devices versus associated devices. Again, that comes on based on question answers that you have with the customer, right? What is your class size? 30 people, right? Do you have the classes which are basically side by side? It is likely that the devices in the next classroom might associate to the AP in this classroom, right? So that would basically help you gauge how many associated devices would be there. And then again, it's in K through 12, usually it's one device per user is what we have seen, right? But again, if you go that and take it to higher ed, like universities and all, you will see 2 or 3 devices per student, right? So again, so all those you can basically modify that and come up with how many users or how many concurrent devices or how many associated devices one AP can support, right? So that gives you, okay, this is my, and this is similar to yesterday when Chuck was talking about the RF capacity from the stadium point of view, where he was focused on just the handheld devices which are one by one, right? So you get basically like 10 devices, what is your aggregate throughput? 50 devices, what is your aggregate throughput, right? So this is basically similar to that in sense that you know how many devices you expect to see, and this is the application requirement. So now you are just doing the inverse math in the sense that you are saying, okay, my RF spectrum can support this many devices or this many users, right? So once you know what single AP can do and what is your single from the requirements point of view, now you basically go ahead and ask questions about, okay, how many users do you expect in a classroom, right? And that would determine whether you need one AP in a classroom, you need two AP in a classroom, or you need one AP per two classrooms, right? So that will help you guide number of APs. You also need to look at how the school is constructed, whether it's a single floor or it's a multi-story school, right? So that will also impact how the how many users you expect to see or the AP you expect to see, and more importantly, how you can reuse the RF spectrum, right? Because if you take the schools in Lower Manhattan, it's a big building. But there are all classrooms which are packed close to each other, and then basically you are going lower level is or lower elementary is at the ground floor, upper elementary is in the middle floor, and sometimes the high school is also part of the same building, right? So then your RF becomes tricky in those scenarios, because then you have to really model it how those RF is going to look like. And then you can basically design your network based on those, right? We have seen a couple of tidbits, and this is specifically in like congested area like Lower Manhattan or downtown Boston, right? I'm familiar with those. So where we had to get the RF right, we had to actually reduce the transmit power to like 10 dB or less on per AP basis. So it's not just providing coverage, it's basically RF for the capacity reason and to reuse the spectrum. You are using a lot more APs, but you are at lower transmit power, right? We had to say the same thing. We had to, and I think that came up yesterday as well in Chuck's talk. We support basically CCI threshold, so that you can determine at the AP level whether you want to transmit or you want to ignore the noise that is coming in. Although you can actually decode that transmission, right? So those are some of the parameters that we play with. But again, the end goal is to create that reusable RF spectrum, right? And depending on the vendors, I know Aruba has similar capacity. Aruba Cisco has similar capacity. Other vendors have similar capacity, whether it's exposed or they basically make it part of their dynamic RF algorithm. But most of the vendors have those capability to fine tune those parameters, right? So again, but idea is find those parameters and fine tune those parameters, right? What we have seen, and basically many times we have heard, is typically for K through 12 is put one AP per classroom. What we have seen is typically that's an overkill from the RF point of view. You don't need that many APs. Many times when it is a single floor classroom, usually the alternate classroom, AP in alternate classroom is sufficient to provide the coverage. If it is a multi-story school, then again you can repeat the same design but shifted by one classroom, right? So that your APs are not on top of each other. You are basically interleaving the AP in Z dimension, right? And again, means you can use tools like Ekahau or Air Magnet to do your RF survey, and means these tools are pretty good to provide those RF heat maps and enable you to put the APs. So now you have basically covered the educational space. Now there are other high density spaces space in school, and this is usually where you have like gym or libraries, things like that. So those are the places where also you need to provide coverage. There, the application requirement is again a little bit different. It's more likely, it's 100% of the time, it's always BYOD, because those spaces are not only used by students, but also you have parent-teachers meeting, things like that, right? So you do expect external guests coming in. The requirement there is more, so it's you have requirement to provide the RF there, but also the requirements in terms of visibility as well as control in terms of what applications you can use. So for example, and this is not really related to K through 12, but we had a library customer where the requirement was, if I'm an adult and if I'm in an adult section, I can basically browse and look at basically adult content. But if I roam and move to kids section, although I am an adult, I should not be able to browse those adult content, right? So that has an implication. Means those requirements requires basically support at the higher level in terms of traffic engineering, security, proxy capabilities, and all those, right? So again, so depending on the space, means you need to look at those, and the requirements, you need to basically look at those policy capabilities in terms of how you police the traffic. And then the next space is, again, outdoor spaces and stadium spaces. Again, how do you provide the coverage? I'm not going to go too much detail into this, because it's similar to what Chuck talked yesterday about outdoor spaces, how you design, how basically your antenna placement and those plays part in it. So again, what it translates into is, specifically for outdoor spaces and even indoor public use spaces, is most of the time the inbuilt integrated antenna solution, like integrated antenna AP solution, may not be sufficient for those spaces. So what you would end up using is either using the external antenna version of indoor AP, or if it is outdoor space, then it is outdoor AP with variety of antennas to provide the coverage and density of that space, to cover the capacity requirement of that space, right? So this is basically, we are just talking about designing your RF space and Wi-Fi network, right? But don't forget the wire, because ultimately all that traffic needs to go through wires, right? I think Kit mentioned last time, right? To know whether your wire link is up and checking that out, it's critical. And means he said it once, but we have seen so many times where those wires in the schools were laid out 10, 20 years back, right? The condition of those connection of those cables means who know what it is, right? So it's important that basically you look at those. You also look at if the again, many old schools where you don't have option to run new cables, right? Just because it's basically the existing cables are running through through places where there is asbestos there, so you cannot really pull new cable, right? And at that point you have to live with fast Ethernet drops, so you don't have even a gig drop, right? So you need to basically consider those requirements. If you are laying down new cables, then again, you should basically talk to your customer and talk about laying down 2 cables or 2 drop per AP location. And again, it's currently you don't need wave 1 11 AC. You can get by using single Ethernet drop, but wave 2 you would definitely need 2 Ethernet drops to support those link rates, right? So it's always a good idea to basically look forward 3 to 5 years, and when there is a labor cost involved, it's way better to basically include that now rather than waiting later. Means you will be surprised when you have a unionized labor and like state like Illinois, Philadelphia, where to run a single cable, you have to basically go through so much bureaucracy, and it's so costly to just run 1 cable. If you say, okay, I want to run 2 cable, it's going to add cost of another 10%, right? So again, versus let's say 3 years down the line, now you have to basically spend the same 100% cost again to lay another cable. So again, it's very important that when you are looking at the deployments and where the labor is involved, and specifically when unionized labor is involved, you basically look further, like 2 to 3 years further down the line to ensure that you are minimizing those costs. So once you have figured out the wired piece of it, next level is basically how, as at a school district level, how that district is laid out from, or basically from the what is the network design for that school districts, right? We have seen that in many school districts, and in fact in some cases at the state level, you would have basically big data center, and all schools are connected via MPLS link to that data center. When you have a case like that, and all your applications or all your business applications are in that data center, right? So when you have those kind of cases, your architectural flexibility at the networking level becomes very critical. Specifically, you have applications which would require, and this is mostly the business application, which would require you to go to those business centers, to those data centers. But then you will have equally or equal amount of bandwidth, or application requiring equal amount of bandwidth, which is you don't want to take it to your data center, right? So whether you support, or basically how you design your network so that you can bridge some of the traffic at the AP, which can then directly go out to internet, versus certain kind of traffic which then basically goes all the way to your data center, right? You need to make those decisions and basically design your policy framework and your network design around those requirements, right? So that was the traffic engineering part. The another thing that we have seen lately in some of the school districts is multi-use scenarios. So what the use case here is, so you use school as a school during the daytime, but then during the evening hours, the school space is changed for adult education or sometimes town meetings, right? So those are the requirements that comes about, and the idea is, can you use the Wi-Fi network that you have in the school for those purposes? Here the RF is not that bigger of a problem, but the policy is. Because when you have, and this is particularly when you are looking at students and, right, there is strict privacy requirements. What it means is, if I walk into the school during the evening hours as a part of a town hall meeting or an adult education class, I should not be able to access any of the privacy records or any of the school assets, right? But I'm using the same network, right? So what it means is, how do you configure your policies for those kind of deployment, right? And you need to, next day morning, again, you need to be school, right? So how easy and how flexible you are, or means what are the tools that are available to you to basically change the network design on fly, right, on day-to-day basis, right? And this applies to K through 12. It also applies to stadium deployments, right? So like one big example that basically at the PM level where we are further away, you basically see this at the like high-profile customers, right? So like Gillette Stadium, so means yes, it's they are providing Wi-Fi during the games, but those are only like 14 to 15 days, and then depending on how Patriots do after playoffs, right? But they also have same number of days for concerts. They also have soccer games there, right, which uses half of the stadium. So again, so it's the same venue, same RF space, but used for multiple, for different purposes, right? And the requirements, density requirement and all that changes for those deployment. And you are not really now going and changing your RF, right? It's basically you are doing it wherever your APs are, wherever your antennas are, but you are now providing different kind of density coverage, different type of policy coverage in the same space, right? So again, how easily you can do it, how you can design for those multi-use cases, and that also determines the success of your network. So again, WLAN or wireless LAN is not one size fit all. So again, each of those deployments needs to be looked at individually, and then as one thing I do want to talk about is as you gain experience there, it becomes easy. We have at Extreme Networks, as well as like in my previous job at BlueSocket, we have SCs who would just go there, do the walkthrough, and they would know, okay, this is how I'm going to deploy the network. And it's an art form. Means they have done it so many times that they know exactly what how they would deploy and where they would deploy. But it takes time. Once you build up those experience, it gets easier and easier as you go further down the line, right? All right. So to recap, this is my last slide. So again, understand the vertical, understand what is the customer requirement, translate those business requirement into the technical requirement, design for simple case in like what one AP can do from the at the AP level and from the RF capacity level. Then basically look at the school geometry and construction, how it is laid out, and then basically decide where you will place the AP, how many APs you would need. Then once you have covered the classroom space, you look at basically other spaces like libraries, gym, or outdoor spaces, provide coverage for that, and then you look at basically multi-use scenarios where the same infrastructure is used for different application at different time of the day. You look at basically at the holistic level how your school district is designed from network point of view, where the key assets are. That will enable you to do the appropriate traffic engineering to optimize your network, right? Once you have designed a network, again, the key is basically do the post-installation inspection just to make sure that things turn out to be the way you want it to be, right? And that's it. Thank you. Any questions?
Yeah, I got a couple questions.
Yep.
So how many devices do you typically see per room? I don't think I saw that in your slides.
So it depends, right? So it depends on, usually what we have seen is some of the rural areas, means you see between like 10 to 15 students per classroom, right? We always basically try to get around 30 to 40 users per AP, right? So, so what that would translate into is you will have basically one AP between 2 classrooms or 3, sometimes even 3 classrooms. Versus once you go into like a more populated area like Boston, New York, right, or means downtown area where in single classroom you have 30 students, right? Or sometimes means in like middle schools you have around 45 to 60 students, right? So there you would put 2 or 3 APs in a classroom. Right. Oh yes. So if you got it that way, then it was my mistake. Then yeah, it depends on basically how what the key thing is, know the business application and what are the device mix that you are going to see. Use that to find out how many device per AP you can support, right? And once you know that, now you go and see, okay, how many means how many students I have in a classroom. And that would help you say whether I need 1 AP, 2 AP in a classroom, or I need basically 1 AP per 2 classrooms, right? Because basically I have only 10 or 15 students per class.
So you've seen in some schools where you've had to actually go 3 APs in 1 classroom?
Yeah.
Do you guys like future-proof, like how long do you build these networks to last for? Is it like a 5-year plan? Like what's the refresh?
Usually it is 3 to 5 years, right? But so there are 2 things that and that's a good question, right? So your number of devices that you need to support, generally for the K through 12, you can really project just because of how many kids you have today and how many kids you can means using the census data you can actually project how many kids you will have in 5 years, right? I won't say that for K through 12, right? Assuming that basically you are already including that, okay, you have 1 device per student. So once you have 1 device per student on average, in K through 12, we don't see basically that increasing significantly over next 2 to 3 years. When you go to higher ed, that's completely different, right? There we are basically, so we use basically our past experience for higher ed, as well as basically we consult like industry analyst and all. So right now on average we are seeing about 2.5 to 3 device per student in higher ed, so basically college education. We are projecting it in next, I think by 2017 or something like that, you would have 7 devices per users. And those devices are not likely to be something that you are going to use it on your hands or something like, or basically you will interface directly like phone, but it would be more like wearable gadgets, like Google Glass is coming or wearable watches are coming, right? So we see those kind of devices increasing in a higher ed arena. For K through 12, again, it's basically school budget, right? And how those districts are laid out, right? So if they say, okay, kid's parent needs to provide all that, those 1 devices are, right? Means you don't expect that many kids coming with at that age with too many devices, right? But once you go in a higher ed, then it's basically wild west, right? So. Okay, so again, it depends, right? So when you have one-to-one initiative where district is providing the device to the kids, what we have seen is you are going basically straight out 1x, right? Because again, it's secure. It's basically you have the control over the network and the end devices, right? So that's what we have seen. When it is a BYOD. It's not necessarily captive portal. Means some of the devices you can actually do like this called onboarding, using onboarding and stuff like that, or mobile IM or MDM, right? That enables you to basically simplify that experience. But yeah, it is similar to basically captive portal.
Are these schools looking to give open internet access to kids that bring their own devices? Or are they, trying to filter that and keep that minimal?
It's controlled. So means we have seen where basically they want to ensure that no more than some percentage of bandwidth is utilized for internet. So that basically comes down to policy and how you deploy those policies, right? We haven't seen basically something where it says no internet, except so when you have the testing period, right? So basically when you have a test going on, then yes, basically for that classroom, you have no internet access.
So the teacher wants the ability to shut down the internet during the test. Is that something you've seen?
Yes. So in general, yes. Means it's not whether teacher wants it. It's more at the policy level. So means we tend to think that okay, teacher wants to do it, but in K through 12 and specifically on public education, it's more policy driven, where there is a procedure which says okay, this is how, means that if it is a test, this is how it needs to be done, and basically so IT administrator have more control and more means they know more, so it's usually done by IT administrators instead of teacher doing it.
You had e-learning, it was like 3 megabytes or megabits down per second. Is that, what is that? It seems like a lot for e-learning.
Okay, the application, right?
Yeah.
So those are the application. Let me just make sure that I'm not.
Is that streaming some kind of video?
So let me think about it. So there are applications where you so this is in basically middle school, where the application is some of the science classes where you are using, for example, biology or right, means where the video content itself is high definition, where kids at the application level, you can actually expand into look at basically one organ at a time, right? So those applications, means those are the specific applications which requires high bandwidth, and that's where it's basically, means it's those applications are rated at 2 or 3. It's HD video, so that basically comes to 2 or 3 Mbps.
You had some pictures too of APs. Did you have with arrows? Were those directional antennas?
Here, this one no. So most of the classroom you would be good with your integrated antenna. You would use the external antenna in public spaces, or basically like gym, libraries, or big lecture rooms where you are basically you are supporting those densities. Having said that, means some of these middle schools where you have 2 or 3 APs per classrooms, sometimes we have seen use of directional antennas. And again, it basically what is your RF space and how you are reusing it, right? So as your density increases, you would need to use directional antennas to provide that spectrum reuse, right? So as long as you can handle the density with standard Omni integrated antennas, APs, you are fine, and most of the time that works. But if means some exceptional cases where you have a lot of students in a classroom, or you have basically spaces where means it's a large space that you need to cover, right? Means a high ceiling, right? So those are the places where you would basically use directional antennas. Well, it means if you have designed it so that it's just providing the coverage, internet coverage, and now you are basically, you want to basically increase the capacity of that network, then yes, that is one of the way that, that you would do it. And that's why, means at the beginning of the talk, I said, right, that many times customers do not know what their requirements are, right? So that's where having that initial dialogue is very important, so that you are educating them that, okay, this is what you should expect. So first try is basically try to avoid to be in that situation, right, where customer is just designing for internet, and then means specifically it's true for K through 12 and almost all the other applications, verticals, right, that you need, means now wireless is becoming mission critical. So it's always a good idea to have that conversation with the customer. But yeah, if you, means things happens, right? So if you didn't have that, or basically because of the budget reason or whatever, they had just gone with internet basic connectivity, then now yes, you would basically need to figure out the RF. But yeah, means at the end of the day, it would come down to adding AP in the most efficient fashion, right? So that we can reuse the spectrum. Okay. Right. Welcome. Yeah.
So
right.
You can put it into your design and kind of ease into it a little bit, because I think a lot of the K through 12 schools are at a loss of how they're ever going to fund stuff.
You are right. Yep. Yep. That's a good point. Yep. Yeah. Yeah.
It's tough. And so, in my daughter's in middle school.
Mm-hmm.
They don't give any devices. But my cousin in Birmingham, middle school, they get a small Google Chrome laptop. So school gives out. And then in high school, they get an iPad. So it depends on the school district and what the policy is. School provided or
Right, exactly. Yeah. Yeah, and means, so when school provides the device, it makes your problem a hell lot easier to solve. Because you have control over the device, you know exactly what device is capable of and how they are going to access the medium. Means you means to the peculiarity of each of the devices, right? Means we haven't talked about like means iPad and iOS devices access wireless network differently than Android devices, right? So you need to basically, means one-to-one is much, you are in much better shape if basically district is providing the device. So, all right, okay. Thank you.